Well, as a matter of fact, when we're going to be talking about bones, we're going to start our conversation first with cartilage. And just briefly remind you that there are three kinds of cartilage. Okay, you remember there's a hyaline, elastic, and fibrous. Fibrous is particularly resilient to the mechanical pressure, to the compression. Elastic is elastic, well, elastic. Hyaline cartilage is the most abundant in your skeletal system. So for the location, again, to remind you, we're going to bring Benjamin here. Fibrous cartilage. All intervertebral discs, pubic symphysis, menisci of the knee, both sides. Elastic cartilage, ears, epiglottis. Okay, can show clearly. Everything else will be hyaline cartilage. Okay. Now, in regards to cartilage, we didn't have a chance before to talk about its structure. We have a chance to talk about its structure now. So structurally, you have a matrix in the center. Okay? Within the matrix, you have empty spaces of sorts. Usually they are paired. Okay, so these empty spaces called lacunae. Within those empty spaces are the cells that actually allow cartilage to grow, so-called chondrocytes. I'm going to put one more right here. Okay, those are chondrocytes within the lacunae. Chondrocytes produce the matrix. Cartilage is sandwiched by two layers of dense connective tissue, like this, that is called perichondrium. Okay? So one important difference between the matrix and the perichondrium, really important sort of physiological difference. Perichondrium is vascularized, meaning that there are blood vessels within the perichondrium. Matrix is not vascularized. And that explains one of the clinical features, the cartilage. Cartilage does not like to regrow back because it is so poorly vascularized. It takes a lot of time for it to repair. So cartilage can grow, and it does grow, albeit slowly, and there are two modalities to cartilaginous growth. One modality is called oppositional growth of the cartilage. So oppositional growth happens when already existing chondrocytes, like these ones, produce new matrix next to the perichondrium. Now, another type of growth, so-called interstitial growth, or growth sort of within the tissue, happens in a different way. So these chondrocytes that are here, they divide, so you have more and more new cartilaginous cells, and those chondrocytes also produce new matrix. Kind of within, okay? So try to imagine this, that in case of oppositional growth, just relatively thin layer of matrix is being deposited next to the perichondrium, while in interstitial growth, cartilage grows really intensely and widens up. So to kind of jumping a little bit ahead and telling you, interstitial growth mechanism for the cartilage is actually responsible for the bone growth during childhood and adolescent years. Something that is really important to understand regarding cartilage is that cartilage doesn't become a bone. It can be replaced by the bone. You see the difference? Like, I cannot become Dr. Nussbaum, but I can be replaced by Dr. Nussbaum. Okay? Good? Questions on this part? On the cartilage part? Because that's going to be it for the cartilage for now.